Hi, this is Wes Simpson with another edition of the Summer Sessions on Media over IP, brought to you by AIMS in the VSF. With me today is Kent Terry, who is Senior Manager of Sound Technology from Dolby Laboratories. And he is going to be talking to us about audio over IP and all of its associated fun metadata. Welcome, Kent.
Hi, Wes. Good to see you.
Likewise, thanks for joining me today. I'm really interested in this because a lot of people are not as enthusiastic about metadata as I think they should be.
Well, today we're going to talk about transport of metadata, because when you talk about audio metadata, you go down a rabbit hole and there's all sorts of interesting topics you can get into. And so what we like to focus on is how we get it from point A to point B.
All right.
And then we can dive into all these wonderful discussions about what the metadata is. So.
Okay,
Very
cool.
interesting topic, very interesting topic. I'm going to do a little bit of background on why the motivation for this. Our topic is specifically about audio metadata over IP, but we got to back up and talk about, okay, what are we talking about metadata? And then where we come from with current production practices. And that'll inform where we're going, where we currently are with IP transport and where we're headed with it. So the first thing is I'm not going to get into all the uses of metadata. There's tons and tons of them, but from the standpoint of most of the audience for this webcast, we're going to be mostly oriented toward broadcast. And one of the big topics in broadcast is next generation audio, to use a generic term. And kind of, as you can see, define some of the pillars, what they call the pillars of next generation audio, which ATSC helped define as part of their ATSC 3.0 work. There's three main pillars that one talks about when you discuss what next generation audio means. And it's a loose term that means audio that's beyond what current systems can do. And so the three pillars are basically immersive audio, personalized, and accessible. So immersive is a catch-all term, and the way the ATSC defines it is something that enables high spatial resolution and increased sense of development. It can mean any number of things, but basically today's production is more or less limited to 5.1 channels, a horizontal plane. And when they talk about immersive, you talk about either increasing the horizontal plane so you get more angles around you, or you introduce things like objects and sound scenes, things that are more than just channels, and particularly one that you introduce a height, the sense of presence of a height channel. So at a minimum, you can call immersive just taking your simple 5.1 system and adding a single height channel. That's enough to call this immersive and give you something that's beyond what today's systems do. But there, it's a catch-all term that means a lot of things. And so even with binaural stereo, there's ways to create immersion. But a lot of these features require metadata, and that's why immersive is such a big deal. It's more than just sending more channels in a lot of cases. There are channel-based systems that do immersive, and I highlight one below, which is 22.2. So if you happen to have 22.2 speakers in your house, yes, you can get immersive with channel-based. It's quite possible. The other two features, one of them has to do with personalization. And this is where it's like, well, today, basically you get a feed from your broadcast station. You might get a second language, you might get a visual descriptive service. What we're talking about is personalization features well beyond that. So for example, if you're watching a sports game, you can choose the kind of announcement you'd want. You want an announcer that talks about the home team or the away team. You may have other preferences about who you'd like as an announcer. Some people are doing it in ad hoc ways these days, but there's ways for broadcasters to integrate these into their primary feed so that the user can select what they'd like to hear. And again, there's opportunity for many, many more languages, and particularly in places like Europe and other geographies, that's really important to have a lot of language support. You can also choose things like level customization. There's a lot more features available for people with, say, hearing impairments, or to tailor the sound to their playback setup. And so you can choose the kind of feed you like to get, and things like, the levels of the background crowd noise. So, these are all elements of personalization. And the final one's accessible. I mentioned different feeds for different types of abilities listener has. And one's dialogue enhancement. And enhancing the dialogue is a big subject about, you'd like to bring out the dialogue, particularly for people that have trouble making out the dialogue. And how you do that, there's a lot of sophisticated techniques that exist to do that, but a lot of them require metadata. And so these are all things that we'd like to include in the next generation systems. And these are all part of audio systems that are part of ATSC 3.0. So we'd like to know how to provide the metadata to do that. There's some formats out there that can be described as NGA. And by formats, some of them are channel-based, like 7.1.4. You'll see that if you go out shopping for home theater system, you'll see that listed as one of the higher end models you can get. So that basically means 7 horizontal channels, a subwoofer, and 4 height channels. And that would get you a pretty good immersive experience at home. Of course, there's a standard for 22.2, which is big in Japan, and some other locations. And channel-based systems, there's standards out there. There's been a lot of productions that do that, so it's a good system. But there's two quote systems codecs that specifically support NGA, those being AC4 and MPEG-H. Both of those are specified as part of the ATSC 3 standard and are chosen in different geographies. But both of those are capable of providing all these different features and immersialization. But as I make the point there in the bottom bullet point, audio metadata is an important part of all of these systems in providing a lot of these features. Even in the channel-based systems, if you want to provide personalization and accessibility, you gotta have some metadata to go along with it. So we're interested in transporting all this kind of metadata, and particularly for live production and live broadcast, we need these to flow over live systems. And so that's where we end with metadata. So on my next slide.
So just real quick, you highlighted time synchronous. How tight does that tolerance have to be?
Well, this is a perfect lead into my next slide. So when we talk about the kinds of audio metadata we need, most people are familiar with audio metadata from, say, your MP3s, song title, artist, etc. And that's certainly a kind of metadata, and that comes into the category of what we call static metadata, which is for a given program or a given stream. In the broadcast case, it may be set up for a particular stream during a broadcast. Certain metadata remains the same, like how many channels you're broadcasting, the sample rate, what the title is, how the channels are labeled, things like this. So, for those systems, particularly when we're talking about an IP link, you can set up your link and you can send that metadata ahead of time and you know exactly what you're getting. It stays constant. But there's other kinds of metadata, which we refer to as dynamic or time-varying metadata. And this is metadata that during the actual streaming of the audio can change, and things like loudness. The loudness can vary over the length of the program. Things like spatial location. When you're dealing with object audio, which is very typical in computers and gaming, the location of the audio you're listening to changes. Think of a game where a character is in front of you somewhere and they move left to right. Well, their spatial location is changing, and that's where you need metadata to describe where that location is. And dialogue levels also change. So there's a lot of different kinds of time-varying metadata, but the common denominator is it needs to be fairly closely aligned to the audio. All of it does not necessarily need to be sample accurate, but our goal with the standard process, which I'll get into later, is to maintain sample accuracy. In other words, we can have metadata associated with audio PCM samples accurate down to the sample level. So we'd like to have that as a feature. There's some applications that might want subsample, but really sample accurate is the golden standard for this. The other denominator between audio metadata is optional versus required. Today's practice, a lot of metadata is optional. That it'd be nice to transmit metadata about some of these fixed parameters, but most systems are set up so that if the metadata is not there, they know what the channel configuration is, they know what they're getting. There's other ways to get the metadata. We're moving into a world with next generation audio where that's not the case anymore, that really the metadata is part of the production. In other words, it's not accurate. You cannot reproduce the audio, you cannot transmit it, process it without that metadata. So these are the kind of distinctions we're making with this. So when we're moving into these new standards we're working on, particularly for IP, we really want to focus on these cases where it's required metadata and it supports this dynamic metadata accurate down to a sample level. We want it to stay with the audio and not get lost. And so the bigger picture, when we look at this, is we'd like to maintain audio throughout an entire chain from production all the way to the end user. So I call that microphone to speaker. So an example is you may have metadata that's captured at a microphone. It flows through the production stage out of terrestrial broadcast, and the user may be listening over headphones. So that's an example where you'd like it to survive a file translation link. You'd like it to transverse a codec and actually be reproduced with binaural information for a headphone. Another example, you may have another source that gets live broadcast, and this is a low latency broadcast that may be transmitted via the web to a television. So you have different transmission methods, different endpoints. And the common denominator is what we're interested in is this live production link. And that's particularly where it's relevant for IP. That's where the world is moving. We're currently in a hybrid system where there's a lot of legacy equipment in there, but we're moving quickly to an IP world, and we'd like to translate that. So there's a whole part of metadata that's going into the mixer, but it's that finished production you'd like to flow through to the point of the emission codec. Of course, once you're at an emission codec, you know, how it gets to the end user, that's a whole other area of operation. So we're interested in that live production mode. So to build up to where we're going with IP production, we have to talk about where we are with current production, or legacy as you may refer it, but basically not IP, which is largely based on, you know, standard AES3 and SDI interfaces. So by far, the majority of live production today is currently stereo or 5.1. There's a few examples of things that go beyond 5.1, but almost everything remains in those kind of common channel configurations. And so, you know, 5.1 was new when ATSC 1.0 came out, but now it's pretty common. Most people can support it. Of course, you get those on DVDs and Blu-rays. Blu-rays, of course, go beyond 5.1, but for live broadcast, it's, you know, there's very few examples of things that go beyond 5.1 right now. And part of that is there is really limited support for audio metadata, particularly this kind of dynamic audio metadata we've been talking about. It's while limited, it works in today's practice. So things do work today within the limits of what we have. Again, with the limitation that we really have not gotten into these new immersive formats. To get into these new immersive formats, we've kind of had to push the boundaries of what we can do with metadata to make that happen. There's some people pushing it without the metadata, some channel configurations, and that can do it. But to really take advantage of these features, we need this. And what we found when we were looking at this, there was a lack of standards. So this going back, you know, 4, 5, 6 years ago when things were really ramping up on particularly ATSC 3.0, we were looking at how do we get this metadata through a system? And we found, yeah, there's a gap in the standards of how to do this. One thing we did notice, though, was the standards that did exist. One that held promise was SMPTE 337. For those of you who don't know about that, it's generically referred to as how to send non-PCM data in AES3. It's basically how to use the AES3 audio signal, but use, instead of sample words for PCM audio, we actually put data in there. It was built in as part of the standard when they first created it. But you know, roughly 20 years ago, there was new standards that came out that kind of coalesced how to use this in a standardized fashion, and 337 was one of the standards for using that. In the past, in the sense that it was first put out, it's largely been used for compressed audio, things like AC3 or MPEG audio, compressed audio, but it's open to any kind of data, whatever you choose to put in it. So a few years ago, we undertook an effort to create some standardized ways of sending audio metadata over AES3 via 337 channel. So it's basically adding new payload types to this SMPTE 337 standard that tell you how to do this. And one of them is ST2109, which is generically referred to as audio metadata AES3 over AES3. And 2109 actually defines a general framework for sending the audio. It does not actually define any metadata itself. It's open to any metadata format. It's a payload-based model, and it was designed around some features that exist in emission codecs. And we're trying to replicate some of those features in the professional domain so that we can send not only metadata intended for the end user, but also metadata used in the professional environment, you know, between the mixer and the emission codec and things that can be used in production. And so we defined this framework, and this standard was published last year, I believe. And along with it, there was an RDD put out that defines an example of a payload-based format, and that was referred to as PMD. And this includes actual metadata, that defines the metadata that's useful for a lot of these next-generation audio features, but it's kind of optimized for 2109. And right now, it's an RDD. It's not a standard. Again, there's a lot of question about what should be a standard in that realm, and that gets into a lot of issues about the metadata itself. We're trying to be agnostic from the standpoint of the transport. We'd like to support anything. One of the actual metadata standards that's really become important recently is an ITU standard, ITU RBS 2125, which we generically refer to as serial ADM over AES3. And what it does, it sends a, quote, serialized version of ADM data, which is another ITUR standard, BS 2076, and it's referred to as the audio definition model. And it's fairly widely used in file formats. And so what BS 2125 does is find a way of take that data that's largely a file-based format and send it in a serialized fashion. So you can send it over live links, and it supports full interchange between file formats. And slight change to this, it has been published now as of late 2019. It actually is a SMPTE standard at this point. And so both of these are fully ratified SMPTE standards and ways of sending metadata. 2109 is format agnostic, open into anything, but there's one format defined, PMD, whereas 2116 is specifically for this kind of serial ADM BS 2125 data. But both of them support sample accurate transport of live dynamic audio metadata. So they both meet the requirements that are needed for next generation audio systems, particularly for things like ATSC 3.0 applications. So what can we do with this? Well, the beauty of going with SMPTE 337, it's been used for a number of years, and it's widely known how to deal with it for compressed audio. And basically, it allows you to send the data wherever an AS3 signal can flow. And we've had lots of experience over the years of where we can send compressed audio. And it's gotten wide use being put into embedded audio with SDI originally and HD SDI, as long as the bits maintain bit accuracy. It's also gone over MPEG-2 transport. I believe it's been transported over MADI in cases. So basically, wherever AS3 can go, the data on 337 can go. And so via this function, we can not only send the PCM audio, but we can send the dynamic metadata associated with the PCM audio. And so this is the view for legacy systems. Of course, it's limited to the number of audio channels you can get over these various interfaces, and it's limited to the bandwidth of AS3. But this is kind of the ideal situation for legacy systems. So if you're dealing with SDI or HDSDI systems, this is the path you would want to follow. In 2116 and 2109 are two key standards for getting those audio metadata over those paths. So now with that as a background, we transition to, okay, where are we headed with metadata over IP? So to give you the background on that, you start with, okay, well, where is audio over IP? Audio over IP has been around for a number of years, well over 10 years in some cases. And of course, there's lots of ways to send audio over IP, but several different companies figured out ways of doing it in real time that's appropriate with live production, both for broadcast and other applications. And a few of them are listed there, and most of them are still on the market and still active. But what the industry found out a few years ago was, well, all these systems are great and they work, but we need some standards for interchange. And that's where AS67 came in. And the AS67 is specifically focused on interoperability between these different systems. AS67 is a fairly mature technology, has been widely used, lots of testing, lots of interoperation, and for sending PCM audio, it's great. But the one thing that's it's lacking has limited capability for metadata, at least as officially built in. And that's the one thing it's kind of missing. It was stripped down to the PCM data only, which is fine. It's just it's missing that key piece of metadata. And as officially defined, it doesn't support sending of non-PCM audio data. And so what do we do about metadata? And when we started thinking about it, we started thinking, well, it's the same situation. There's lots of ways to send metadata over IP. You can define all sorts of methods. IP is data. But we want standards for interchange, and we want standards that work and are compatible with the requirements for live broadcasts. So they fit in with AS67, and as we'll mention in a minute, the 2110 suite. So that's where we're looking. It's like, okay, where can we have standards? Now, most viewers of this web series will, of course, be familiar with the SMPTE standards for media over IP, but the key relevant ones that we'll discuss for when we talk about audio metadata over IP, 2022-6, which is basically sending SDI type of audio over IP as a strict entity. That's a key standard, but as well as the 2110 series. And the 2110, of course, being kind of the future where we're headed with this, and particularly since it supports I/O with legacy SDI systems in the right mode. And the key standards that go along with this that we're going to discuss that are important for sending next generation audio along with metadata is, of course, 2110-30 PCM digital audio. I'm sure you've had other presentations on that. It's based on AS67. And as I mentioned, it's wonderful for transmitting PCM audio. It just lacks this kind of feature we need for sending metadata, which is non-PCM data. That's one of the reasons that the standard 2110-31 came in. And that was defined a couple years ago within SMPTE to transport not just PCM audio, but transport an AS3 signal transparently. And it was recognized that this is needed for compatibility with legacy systems, particularly those that carry compressed audio using SMPTE 337. And so this was based on the existing Ravenna format, but it allows one to carry over an IP link within the defined 2110 suite full AES3 signals, and that includes support for non-PCM data. And so between these two standards, we end up with a situation, which you'll see on the next slide, where this is how we can today, with the existing standards that are in place, send audio metadata, audio PCM data with dynamic metadata that supports these next generation applications and is in fact compatible with legacy SDI systems. And that's basically saying use one of these two standards that exist for how we send audio metadata via 337. And similar to the legacy system, we can send AES3 wherever the AES3 signal flows. And so one of them is by extension 2022-6, which can incorporate the audio and the metadata in embedded audio channel that's put in 2022-6. You can also send it over Metadata Transport Over IP. There's another standard for doing that. But in the case of the 2110 suite, we can send the audio metadata over 2110-31 as well as the PCM audio. Now, I do highlight there the one key mismatch there, which is we'd really like to send audio over 2110-30 because that's the way to send PCM audio in the 2110 suite. 2110-31 is great if you need AES3 compatibility, but we really like to coalesce around the 2110-30. And what we are lacking right now is a standard that defines, well, what is the metadata path for audio in 2110-30 or equivalently AES67? And so that's kind of the missing piece in the standards. And so when we thought about that, it's like, hey, what we'd like is a native path to match that. Where can we send this audio? And so a few years ago, we at Dolby proposed a method for doing that that was compatible with this 2109, again, anticipating where we were headed with 2109 and legacy systems. And we proposed a method to take this 2109 wrapped data, and instead of putting it in the actual AES3 interface, just take the container itself and map it natively to an RTP stream, and then send that in parallel with the 2110-30. And as many of your viewers will know, the 2110 suite is built around the concept of parallel RTP streams, all with a common timing reference. So they can all be maintained. So different essence flows are separated out in different data flows, but they can all be combined together at the receiver in a sample accurate fashion. So it maintains that timing. So when we talk to the people with knowledge of AES67, rather than trying to modify the standard, it said, hey, send a parallel RTP stream. That's the way to go. And so a project was started, which I'll talk about in a minute. It was decided to start this project in the AES, so it would be compatible with all AES67 applications. And the proposed draft standard was AES X242. And that is currently in active development. And that's what we'll be discussing here. But that's the vision for this, is to take the data, the audio metadata, wrap it natively to an IP interface without the constraints of the legacy systems, that bandwidth limitations, the other constraints that you deal with when doing AES3 wrapping. And then you have not only bandwidth, lose the bandwidth constraints, but you have much more control over the timing of the metadata, and you really do have full support for these next generation applications, not just next generation audio, but a lot of other applications that we see coming that can benefit from this. So that's what was proposed. And so this actually describes the project. It's a separate RTP stream to go along with the AES67. And again, its scope within the AES standard is limited to AES67. It's only focused on, okay, you have an AES67 signal. We'd like to send audio metadata with this. So, of course, you can send this stream by itself, but it's really intended specifically for that use case. And in the spirit of what we discussed with 2109, it's meant to be a transport system that's format agnostic. We're not trying to get into defining the metadata in this project. It's taking data that's defined elsewhere and figuring out how to transport it in a manner that's compatible with the applications. And in the case of AES67, it's got lots of use cases in the industry, not just broadcast. And we'd like to be compatible with all those applications that would benefit from metadata. So, if you go look at the project, this is a link to the project page, which can give you the public information on the project. And there's some key features in there, which I just, highlighted about what's behind the scope of this is metadata with AES67, both the static and dynamic time synchronous metadata with AES67, and extensible It's format agnostic. We're not tied to a specific format. So if new metadata comes out or metadata becomes obsolete, gets replaced, you can stick with the same transport method and gracefully translate to these new features. So that's the project in the AES. So how does SMPTE get involved in this? Well, there's a parallel going on the video side. So I mentioned how, we said, okay, 2110-31 is a great method for sending the audio metadata in parallel with the PCM audio that's in a -30 stream. Well, the corollary on the video side is ancillary data. So in the case of SDI, we have all this kind of data associated with the video signal and or the audio signal that's buried in the ancillary data in the SDI interface. And so as part of the SMPTE 2110 suite, they defined a method for translating this over an RTP payload. And that's 2110-41, or 2110-40, sorry. And it's specifically targeted at transporting ANTS data packets over an RTP link in a manner that maintains compatibility with legacy SDI systems when needed. So this is exactly a corollary to saying, okay, we want to send this audio metadata. So this can be considered like metadata associated with a 2110 video signal. And so this is great, but it's open to any kind of data. You can define any kind of data you want to put in an ANTS packet, but it does have the limitations of the ANTS data structure, particularly the fact that it's formatted into these words that are 255 data words maximum, which, most applications is fine, but there's a lot of future applications we can think of, particularly with rich kinds of metadata where you extend that limit. So it's a little bit of a kludge to try and format into the multiple packets. So realizing this, some people on the video side said, hey, we kind of need the same thing. We need a different way of sending metadata when we're not concerned about legacy compatibility with SDI systems. So for purely IP links, we'd like the way to send metadata associated with these 21 signals in a native fashion that's not tied to the legacy ANT structure. So a project was proposed a couple of years ago, generically referred to as fast metadata. And it's an approved project now, which is SMPTE 2110-41. And it's very similar to the ASX242 project. It's trying to define a way of transporting in a synchronous manner compatible with the 2110 signals, arbitrary metadata. And again, data that may not be appropriate for wrapping in an ANTS packet. And as with ASX242, it's not tied strictly to any type of metadata. It's format agnostic. The difference in scope is ASX242 is limited in scope to audio metadata associated with AS67, whereas -41 is open to any kind of metadata. So wide open scope. And so, but looking at the project scope, as you can see there's a lot of similarities between the two projects. So realizing this, what we have going on is an attempt to harmonize the two systems. So we have a liaison set up between the two groups within AES and SMPTE working on this to say, hey, can we harmonize these efforts? It'd be really great if we can share the same basic format. And in practice, what that means is what we're looking at is so they can define a common RTP format that can be shared, whereas X242 would send just a subset of audio metadata in a manner that has the constraints needed for audio, whereas 2110-41 is open to all sorts of metadata. And again, there might be a SMPTE constrained version of this that says, okay, well, here's a SMPTE version of X242 that works with SMPTE 2110 links. But that's the current goal, but it meets the same goal. It's still compatible, free of the legacy constraints that we have with this tunneling, and it's open to all this next generation metadata. So that's where we sit with the standards with these things. The goal is the same. It's just exactly how we get there is what's under discussion. But the end result is the same. We have a way of sending this rich metadata we need for next generation applications along with the 2110 signals and or AS67 signals. So that's where we're headed. So where things sit today, we have two active groups working on this. And as I mentioned, one of them is an AES, and that happens to be the SC0212R task group on streaming audio metadata over IP, which I happen to be the task group chair of. And that group was assigned the role of developing this X242 standard. And we actually started work in 2017 and got a lot of work done last year, but the recent developments, of course, been on this harmonization effort. We've also been seeking user input on the use cases for this. I'll highlight some of those in just a minute, but that's where it is. The one thing that we're headed to is the group is coalescing around a standard. We have draft standards pretty close to being ready. We're hoping by the end of this year we'll have the draft standard ready to go, but we still need a lot of work on development, testing real implementations, particularly validations against user requirements. So if any of your viewers of this webcast are interested in this topic, the group is still active and welcomes input and participation. And even if you're not able to participate, if you have input on user requirements or use cases, you're certainly welcome to let the group know, and we're happy to figure that in our plans. Now's the time to speak up before the standard is written, to make sure your applications are covered and we can handle your needs and requests. So on the SMPTE side of things, the work going on 2110-41 associated standards is happening in this group, well known to this group, the SMPTE 32NF-60 Studio Video over IP drafting group. And there again have a draft standard in development for -41. It's moving its way along, and hopefully it'll be further towards publication, say in 2020, 2021. But we've seen good progress on that. Again, it's still in draft state, so there's still a chance to affect how that works. So again, I'd encourage your users, listeners of this webcast, if they're interested, to get involved and participate and provide your input on it. I should also mention there's another project recently started in the PC working on file mapping, and I mentioned in the first slide how we'd like this metadata to survive file interchange, and there's some work going on to define a mapping of next generation audio signals, including metadata, to MXF. And that's a just recently started project that is a corollary project to this that helps keep that link so we can maintain that translation between file and live links. So for all these groups, they're all active and in development. You're welcome to get involved and participate. So these are just a listing from the X242 group of some of the applications we see. Of course, a lot of your viewers are familiar with live broadcasts, but we see AS67 used a lot in these other applications, including music and film production. So it's not necessarily live broadcast, but the production itself is live, and you particularly need low latency. Live sound is another application. We have examples where advanced audio is used for live sound. We've got some interest on the radio side of things, believe it or not. There's interest in radio there. And of course, just general audio streaming. So we'd like input on all these applications. So if any of your viewers have input on this, the SEO212-R group would certainly welcome your input. And my final slide is just a brief consolidated listing of the standards that are relevant. I've covered all these in this talk. Most of them are standardized, but the two that are in active development, those are the ones where I highlighted, work is actively going on and could use input. So, hopefully this time next year, those two standards, -41 and X242, will be well on their way to publication or draft publication. And so hopefully by the end of 2021, we'll see something out there and actually get some applications out there using them. So that gives you kind of an overview of the lay of the land of where things are in today's production, how we see a method for IP that works with legacy systems so that we're fully compatible with interchange with legacy systems, and a vision for the future for all IP systems where we have these unconstrained things that not only meet the requirements of these next generation audio, there's a lot of features we see for just audio in general where we can envision this cloud processing and advanced audio capabilities, and we have this opportunity now for live workflows to have this rich metadata that's been used in file formats for some time, and enable a lot of these features that you see in other applications like gaming, things like that, where they make use of this rich metadata. So we're excited that these standards are in place that users can start using this to start to enable these new services that really provide something of significant value to the end user, that they really see some changes coming and where things are going. So that's the whole goal of this, is to get over these hurdles we've had in legacy systems and provide these new features to really help your users keep broadcasting relevant, keep viewers engaged, and provide new services that keep those revenue streams going. So that's where we sit with things, Wes.
So thank you, Kent. Really appreciate what you talked about. There's a lot of things going on there. So what are the real benefits of having this synchronized metadata for somebody who's primarily concerned with broadcast television? What kinds of things are people going to be able to do with it?
Well, for example, some people say, I don't really need this next generation audio, or I can't rely on this metadata. Just in current production practices, just keeping track of all the channels has gotten to be a big deal. particularly with all the different languages and feeds. And SDI is lacking the ability to put this metadata into tag systems. But with new IP systems, we have lots of ways that we can identify this data. And so even if you don't need this, next generation audio data, there's a lot of metadata that would benefit production practices to keeping track of things, doing, quality control, monitoring channels. So just in production practices, we can see this being helpful. But if you really want to enable these new services, this is a way to make sure you provide this data in real time to a mission encoder. And a lot of these, next generation audio systems like MPEG-4, MPEG-H, and AC4, we can feed these to an encoder and really start to provide signals to the end user. So it's a really, look at it as not just helping your production practices, but a way to enable new features that you can send downstream to your end viewers that they can make use of.
So ATSC 3.0, you mentioned it a little bit at the beginning, and also some of the cloud technology, some of the cloud processing functions seem to be ripe for exploiting some of this metadata. How do we, how can we benefit from doing this, and what needs to be done to make it really happen?
Well, again, the carrot of IP is enabling these new cloud functions. It's hard to enable cloud processing features in an SDI-based system. Once you're on IP transport, the whole world opens up to these technologies. And it doesn't always mean necessarily in a cloud. It can just be cloud technologies that are local. But you can apply all these techniques that are widely used in the IT industry, function virtualization, spin-up processors. So we're no longer tied to like single boxes to do this processing. You can spin up instances of cloud type processing to enable whatever kind of feature you want. So, dialogue enhancements is a good thing. You can send from the microphone information about how the microphone is capturing the signal, and you can use sophisticated processing that, maybe more than a single instance of processing can do, but you can like do neural processing in the cloud that can give you advanced ways of handling this dialogue level that can tag this and send it down to the end user. So what the end user ends up with is a superior experience of being able to tailor the dialogue level, pick the dialogue out of the noise, and particularly for hearing impaired people, to raise it, boost it in a manner they can understand. So that's a simple example that even without next generation audio, it's just helping improve the clarity of your program you're sending to the end users. And of course, you can do much more sophisticated mixing as well, but it opens up the world to all sorts of kinds of features that one can do when you start to envision lots of audio channels, lots of metadata, lots of processing, no longer limited to what a single box can do with a single firmware instance.
Sure. So you've been pretty busy, and I know the rest of the standards organizations have been busy creating these new standards in both AES and SMPTE. What's the next step in the process? Assuming these things come out in 2021, like you were mentioning.
Well, as I kind of highlighted, we're fairly far along in the draft standards. They're not out for ballot yet, so there's still work to be done. But I'd say they're fairly close to being complete and ready for balloting and review at a higher level. So hopefully in the next few months that'll be wrapped up. But there's still a window to get some things done, and of course then it goes through the process. But beyond that, we want to make sure that these standards meet the requirements, particularly things like latency and bandwidth. And we'd like to get some applications built to test those out and validate it meets those requirements. And of course, interoperability, as you know, with 2110 and AS67 is a big deal. And we need a lot of different implementations of these. We need to get some users interested in implementing these and actually testing the interoperability and make sure this works. And once we have that, I think we're in a good shape. So I see going into 2121, that's kind of our focus, is making sure we have all the pieces of the standard in place and focusing on getting implementations and testing and validating and interoperability. That's where the action is in the coming year.
It makes a lot of sense. So do you think we're going to have any big interop events on this stuff coming up, or are we going to do it all virtually again?
They're not on the radar right now, but hopefully by the time we're ready for the virtualization, we'll actually be able to get together and do some actual virtualization events. But all this is happening at a very interesting time in the industry, when people are working from home and doing things like webcasting from here, and this all speaks to where the future is headed. All this kind of cloud technology, and so I think it's an opportunity to change things and how we do this. And so, particularly with this is a lot of this stuff can be done remotely, and not necessarily don't have to be in the same physical location. So I think we can accomplish a lot, even though we're all working separately in different places, not just on the standards, but on the testing. There's lots of opportunities to do this. So
Cool,
it's
cool.
an exciting time in the industry. So hopeful, when we come out of this whole phase of pandemic, we're going to see some exciting changes.
All right. So now all thanks for that. Now all I have to do is convince somebody else in my household that it's time to install another 24 speakers around the TV and make that all beautiful and wonderful, huh?
Yeah, 22.2 is a bit of a hard sell, but start small. I highly recommend soundbars. They're great investments and great technology, and believe it or not, they give you an immersive experience enabled by metadata. So.
Yeah, I've been very pleased with my soundbar. It's really really changed the way the TV sounds. So that's been pretty good. Well, this has been great, Kent. Thank you very much. I appreciate your time, and look forward to hearing more about this as it continues to develop.
Okay, well, we'll keep your listeners informed, and as I said, if they have any input for us, we welcome their input on the standards group. So.
Great, and yeah, all the contact info they needed was put up on the slides before, so that's good. It's always good to have people be able to join these groups and participate if they feel passionate about things.
That's what we need.
A big feature of the open standard. So do you think we'll be able to go back to movie theaters and experience all this stuff soon?
Well, the jury's still out on that one, but I haven't touched on the theater side. There's some people that are pretty passionate about movies. On a cruise last summer, thankfully, but I observed that there are a lot of people that are passionate about cruising. Cruising will be back, and I'm convinced movie theaters will be back.
Yeah, I think you're right. I did a cruise last summer, and I can't wait to go again. It should be fun.